Today we're going to go over derivatives of logarithmic functions. To start, we're going to look at the natural log of x. So if I give you f of x is the natural log of x, then our derivative will be f prime of x is 1 over x. For this section, it will be really important to remember the properties of logarithms. So the three properties I want you to think about, and the first one, the log base b of m times n, I can expand that to the log base b of m plus the log base b of n. So anything that looks like multiplication, I can separate and make it addition. Very similar to that, if I have the log base b of m over n, then I can make that the log base b of m minus the log base b of n. So when I multiply, I add. When I divide, I subtract. And then the third one, the log base b of m to the p, that p can come in front, and then I have times the log base b of m. Sometimes I know this can be confusing in calculus because we've covered a power rule where powers were coming down. Notice this is not the same. This power came down, became a coefficient, but I'm not subtracting 1 from the exponent. This isn't the derivative, it's just bring the p down. So make sure you're paying attention to why am I using the rule, am I taking the derivative, or am I just rewriting the function? Okay. So let's take some examples. So we'll start with 2 times the natural log of x plus 3x. So this is my f of x, and I take the derivative f prime. The natural log of x I know is 1 over x, so that 2 I'm just going to put in the numerator, and I have 2 over x, and then the 3x is 3. If I give you g of x is the natural log of 5x plus 9x squared, well, notice this 5 is belonging to the x. It's not the coefficient of the natural log. It is right there with the x. So I want to first separate that out. So here I have g of x would be the natural log of 5 plus the natural log of x squared plus 9x squared. So I wanted to separate the natural log of 5x into two terms, natural log of 5 plus the natural log of x. The natural log of 5 then, do you see it does not have an x in it? It means it's a constant. So when I take the derivative of the natural log of 5, it's going to be 0. So you can see that g prime of x, the natural log of 5 is gone, it was 0. Natural log of x becomes 1 over x, and plus 9x squared, derivative is 18x. Let's look at this. F of x is the natural log of x cubed minus e to the x. Okay, once again, I have a case where I need to expand, and this expansion is I want to bring that 3 in front of the natural log. This is still the function. I haven't taken the derivative, so all I was doing was rewriting the log. So now I'm taking the derivative of 3 times the natural log of x minus e to the x. That derivative will give me 3 over x minus e to the x. Well, let's talk about what if we didn't have natural log. What if we had a different base? So if I have the log base b of x, the derivative is 1 over x times the natural log of b. So there are some similarities here between natural log and log base b. They always become 1 over x. The difference is I'm attaching the natural log of b when I have a base different than e. Okay, so let's find some derivatives. So we'll start with the log base 3 of x. So the derivative of log becomes 1 over x. This 3 I need to write as the natural log of 3. If I give you 4, log base 5 of x minus 2x. So this 4 goes on top, the x goes in the bottom, and then this 5 becomes the natural log of 5. Minus 2x is just negative 2 when I take the derivative. Okay. Quite a bit bigger, I have 3 times the log base 2 of 5x squared. So this 5x squared needs to be expanded before I can take the derivative. So I'm just going to keep the 3, and I'm going to separate this into the log base 2 of 5, and then I'll also have the 3, and I have the log base 2 of x squared. Now that the x squared is by itself, I can move this 2 into the front. So this 2 is coming along with this 3, and it becomes 6. So I'll have my 3 log base 2 of 5 plus 6 log base 2 of x. Again, remember, this is not the power rule happening here. This is me rewriting something for logarithms. 3 log base 2 of 5 does not have an x in it at all, so I know that's a constant and the derivative is 0. The 6 log base 2 of x, we'll leave that 6 in the numerator. The x goes in the denominator, and then I have the natural log of 2. All right. So here's 3 examples for you to try. Remember, use those rules of expansion whenever they're necessary, and let's see how you can do. Okay. So let's start with this 3 ln of x plus 2 log base 4 of x. So the derivative of 3 ln of x is simply 3 over x. The 2 log base 4 of x, I'm going to keep the 2 on the numerator, the x goes in the denominator, and then the natural log of 4. Where I gave you the natural log of 1 over the square root of x plus 6 log of x. Couple things going on in this one. All right, first let's start by rewriting that 1 over the square root of x. Because it's a fraction, I know the exponent should be negative when I rewrite it. And because it was a square root, that becomes 1/2. So my natural log of 1 over the square root of x, I can write as natural log of x to the negative 1/2. And then the 6 log of x, I didn't do anything. Okay. Again, this exponent here becomes a coefficient over here. So I have negative 1/2 natural log of x plus 6 log of x. When I take the derivative, I have that negative 1/2, but I also have 1 over x from ln. So I just put those two together and said that would be negative 1 over 2x. Then for 6 log of x, 6 goes on top, x goes on bottom. Remember, this is common log, so even though I didn't write the 10, there's a 10 in there. So you want to make sure you compensate for that and put the log base 10 in your denominator for the derivative. And then the last one, I have 5 to the log base 3 of 2 over x. So I wanted to make sure we did one where we had to subtract, since we've done so many that we multiply. So I'm going to expand this out. I have 5 log base 3 of 2 minus 5 log base 3 of x. Once again, we have a term, which is this 5 log base 3 of 2, that does not have an x in it, which means it's a constant, and it's going away when I take the derivative. So what I am left with is the negative 5, which goes in the numerator, x in the denominator because I took a derivative of log, and the natural log of 3 to show me that my log was base 3.